So this may not look like the best place to start. A white, old male, kind of an okay boomer looking at us. But this is René Descartes, and for better or worse, he is the godfather of Western modern civilization. And he was at a crucial junction in European history. And we don't have the time to go into his philosophy or understand how and why that happened. Of course, being a philosophy teacher, I'd love to indulge a 5-hour explanation of it. The point here is simply to say that, as a fact, how we understood nature after Descartes fundamentally changed. And he was part of a time, the late Renaissance, when humans started to see the world rather like a machine. Now, at the beginning, it seemed as if the best metaphor for a machine would be a clock. That's how Newton, for example, understood his physics, that he was understanding the mechanical cogs and wheels of the great machinery of the universe through the laws of gravity and so on. But I think it's probably best if we put up an image of a slot machine, because this is how we have come to understand nature. Because after the Renaissance, after the Enlightenment, we had something called the Industrial Revolution, in which we managed to extract a huge amount from the earth and from this great machine with our own machinery. So we have this understanding, this natural background understanding, to see the earth as a resource which we can extract things from. Now, in many ways, this machine is very predictable. The climate change, for example, is just down to some very basic principles of chemistry and physics. But there are, because it's such an enormous machine and it's a complex machine, there are many ambiguities in how the whole thing functions. But now's not the time to get into that. The concern that we have in this first step in understanding sustainability and putting it in a wider perspective is the fact that our extractions and our climate change emissions have pushed this machine to breaking point. Now, when I was a young boy, I had a ZX Spectrum computer, and there were certain games which required me to run at great speed by tapping the keys extremely hard and fast. And in the end, of course, I broke the keyboard. And we are now approaching, because of the Industrial Revolution, because of the booming population and what is known as the Great Acceleration of population and consumption since the 1950s, we're now approaching what we call planetary boundaries. So here you can see a map of the key planetary boundaries. Now, thinking about the world as a machine has this one major negative consequence, and that is that we consider it pretty much as an object. Now, now's not the time to get into different macro understandings, or let's say meta understandings of nature and ourselves. Let's just run with this idea of nature as a machine, because that's the one that we've primarily inherited. Because actually, I think that inside this conception of as nature as a machine, we, even within that framework, we seem to have lost some notion of the fact that the machine has got limits, that the machine can break, and the machine can't carry all of our demands. And in fact, we can even if we consider our body as a machine, this gives us a helpful way into the crisis, into the climate crisis, and into a way about thinking about the whole of the sustainability crisis. Because we understand from the inside that the machinery of our body has got certain limits. We understand, for example, that eating 1 bag of crisps doesn't have hardly any consequence, but eating 10 bags of crisps a day will surely have an impact on your life expectancy. So we do understand, as an approximation, our own bodies as machines which need to be looked after, and therefore by consequence we can start to understand nature a little bit. So to get this whole thing going, we're going to acknowledge our debt to Descartes and the fact that in Western thought we tend to see the world as a great mechanism for us to extract things from. But we're going to use that idea as a starting point to get us into a system, a wider system framework of thinking about sustainability.
So I'm outside the University College London hospital, in fact the emergency department, and more precisely the children's emergency department. If we just say a word about that before we get going into the details, the climate crisis of course impacts our students more than it will impact anybody else. The acceleration of greenhouse gas emissions, the acceleration of the proximity of tipping points, if anybody's going to be affected by this, it's the younger generation. So symbolically then we come to the children's emergency department. This is climate emergency. But I'm here to talk about something more specific, and that's temperature. Because if we think about temperature and the way that it's generally taught, or the way in which we naturally understand temperature, as we think about it in an individual way, we think about temperatures. For example, this is London, it's 24 degrees today, and if we added an extra 2 degrees to today's weather, then most people would quite be appreciative of that. I mean, that would be a little bit nicer, maybe we wouldn't have to wear this little jumper. But if you think about temperature on a systems level, not an individual weather event level or a local level, then things shift and the understanding becomes much more complete. So part of the Green Comp framework is about getting students to think about things at a systems level. So that's why we're here at this A&E department, is to talk about temperature at a systems level. So if I had a temperature, body temperature, which was elevated by 2 degrees, then I wouldn't be doing this video. I'd be sat in my hotel, I'd be feeling sorry for myself, I'd be maybe watching cricket on the TV or something like that. So I would just be feeling lethargic, I would be feeling with a very low energy, and that's a 2 degree fever. Now, that is because my body is designed, it's been evolved over millions of years to function at a certain temperature. And you can't just put it up by 2 degrees and expect the thing to carry on functioning. And the planet is exactly the same. The planet is just a much bigger, complex biosystem. And its operating status, like its main operating level, was the pre-industrial average. It was essentially 0 degrees. But over millions of years, all of life on Earth has evolved and functions at that zero. So if you put it up by 2 degrees suddenly, and we've already pushed global temperatures up by about 1.2 degrees already, then you can start to see that things don't function properly. Now, when we talk about temperature in the classroom, or when we teach temperature, we have to put it in the systems framework. We have to frame the problem of temperature in a systems way, otherwise it doesn't make any sense. In fact, if I had a body temperature of 4 degrees over the average, then that, in medical terms, is called hyperpyrexia. And hyperpyrexia is a medical emergency, so I would be in here and I would be receiving emergency treatment, otherwise I would die within 24 hours. So when you start to understand why the Paris Agreement of 1.5 and 2 degrees, why do scientists say that this is the safe level for humanity, was because that's a global average temperature which is understood at a systems level. And it's that systems understanding which is missing when we teach it. And that is what we got to get students to fully appreciate, why climate change is such a major issue. This is why it's an existential threat. If we only teach about temperatures in terms of more floods or more heat waves or things like that, then of course it's a local problem with local tragedies and everything. But until we start to understand things at a systems level, we won't appreciate and we won't engage with the crisis with its true depth and with its true scope. So when you start thinking about Earth as a system, just like your body is a system, or for example a laptop, that's a system that's wired to function at, let's say, 110 volts, and you can't expect it to function at 140 volts or 180 volts. When you start thinking about the Earth as a system like that, then some things start to become clear. So the Amazon rainforest, for example, which is likely to collapse at around 3 degrees of warming, then you can start to see how that has an impact across the entire system. So the reason why 3 degrees is important and is because you can't risk destabilizing all of Earth's systems. And the Potsdam Institute mapped out the key components of the Earth system. You have the boreal forest, you have the Amazon rainforest, you have the permafrost, and each of these systems plays an important role in the functioning of the whole. And in a complex system, you simply can't mess around with one component without all the others being affected. So being in front of a hospital and thinking about the body as a system, that helps us with this green competence of problem framing and systems thinking.